Hello, good morning everybody. Now this chapter I am teaching you, that is context-free grammar, and the most important part of this context-free grammar is the expressions of the production rules as the generation of derivation of the tree. That means expressions of the production rules of the context-free grammars as the derivation tree. What is derivation tree? That means the definition is that a derivation tree, sometimes it is called the parse tree. It is a derivation tree or parse tree is an ordered rooted tree that graphically represents the semantic information a string derived from a context-free grammar. That means grammar is nothing but, we know in the class that the grammar is nothing but the production rules, and all the production rules will help us to generate the string, particular string. Okay. So, for a particular strings, we will use our production rules, and all the steps when will be imprinted as the or depicted as the graphical formations, then it is called the derivation tree, and sometimes this tree is called the parse tree. Okay. So, what are the parts of the derivation tree? So, to represent the derivation tree, we need the root vertex and the vertex and the leaves. What is root vertex? That means the starting symbol. We know, we are familiar to the starting symbol, and here this root labeled S is called the root vertex, and all the nodes, that means all the nodes labeled x1, x2 and so on xn. So these are called the vertex. Okay. So first is called the root vertex, and these are called the vertex. And what are the leaves? And the end nodes. And the end nodes which ends with, and the end nodes whose level is the small letter, that means terminal, is called the leaves. If S produces x1, x2 and dot xn, then for the CFG, then the parse tree will be like this: S and all the wings like x1, x2 and dot xn will be in the tree. Okay. Now here it is the example. Suppose the A, B, A, B, B, these are the string you have to produce by using all the production rules. What are the production rules? Here the production rules is S produces SS, oblique ASB and oblique null. And now this is the production rules. Now this way we used all the production rules to have this particular string. Now S produces SS, we replace the value of S by ASB and S. Now we put S is equal to null, then we get the ABS. After that, again we replace this S by ASB. Again we replace the S with ASB, and ultimately in the last stage we put S is equal to null, and my desired string is got. So for these steps of the production rules, if I depict all these steps in the form of a tree, then tree will be like this. That means at first S produces SS, that means S produces S and S. After that I put here the null for the S. So I put, then again I split this S as ASB, that means ASB, and here I put then I put null for S. So here I put null for S, and again for these strings I split again S to ASB, again split S to ASB, and ultimately here I put S is equal to null. So here S is equal to null. So this is the parse tree for these production rules to generate this particular string. Now, the sentential form and the partial derivation tree. What are the sentential form and the partial derivation tree? This is the given production rules for a CFG. Okay. So the partial derivation tree can be the following. If I follow any of the production rule among these production rules, so the graphs for that particular production rules will be called the partial tree. If I plot this, so that will be partial tree. If I plot this, that will be partial tree. If I plot this, that will be partial tree. So now I choose S produces AB, and here the graph is S produces A and B. So this is the partial tree. Among all these production rules, this is only for one production rules, that is S produces AB, and the partial tree is S produces A and B, and this is called the sentential form. If any partial tree, if I found the S node, then it may be called the sentential form. Now come to the leftmost and the rightmost derivation of the string. What is leftmost derivation? This is the definition. A leftmost derivation is obtained by applying production to the leftmost variable in a step. That means a leftmost derivation is obtained by applying production to the leftmost variable in the each step. And a rightmost derivation is obtained by applying production to the rightmost variable in each step. That means from this example it will be clear. Everybody look. That is, here these are the production rules are given for a particular CFG. Now what I will do to have this string, I follow the leftmost derivation. From this particular derivation, first I choose these production rules. Okay, and here I choose the leftmost variable, that is capital X, and I put the value X produces A to the leftmost variable, that is A. So this is the left part. I choose the leftmost variable. I choose here the leftmost variable, and I put the value for this leftmost variable, and the other parts remaining same. Then again I split this X. This is the variable. So this is, I take for this X is X cross X. The X cross X. Again I choose the leftmost variable capital X, and I put the A for this, and again we have the A plus A star X. Again X is there, and last of all I put the value X produces A here, and ultimately the string obtained is this. So I have to obtain the string this, and here I obtain the string this by leftmost variable, because of here I choose the leftmost variable first and putting the value in the leftmost variable gradually, and I already obtained this string. And if these all steps is depicted in the form of the tree, all the steps will come. You see, for the step 1, that is X plus X. So X produces X plus X. Okay. For the step 2, what I have done, I choose X. I choose X and put the value of A. So here for the left part, I put the value of X as A. Again for the step 3, what we have done? We explored this X to X crosses. So here we explore this x for x cross x, and again we put for the step 4, again we choose the leftmost variable and put the a for this. Again we choose the leftmost variable and again we put the value and value a for the step 4. And for the step 5, what we have done, the last x will be eliminated by a. The last x will be eliminated by a. So these are the parts 3 of this productions of this leftmost derivation tree. So these are the leftmost derivation trees. Okay, and again now you come the example for the rightmost derivation. What we have done here, to have this string, we now choose this production. We choose these productions, and here the rightmost variable is x. We put the a for this, and again we explore this x as x plus a, and again we choose the rightmost variable x and put a, and last of all we put the values of x and we will have this. And similarly, if we depict all these steps in a parse tree, we will have the step 1 tree, step 2 tree, step 3 tree, step 4 tree and step 5 tree, and these are the parse tree of the above production rules. Okay, these are the rightmost tree. So whenever we explore the left variable in our production rules, that gives the leftmost derivation tree, and whenever I choose the rightmost variable in our production rules and explore that variables, then it will produce the rightmost derivation tree. And rightmost derivation tree and leftmost derivation tree is equivalent. In the next phase of the class, I will discuss that portions. Thank you very much.